answer any questions. We have a proprietary liquid catalyst. In the scheme of how the industry works, is non-toxic by comparison. In other words, it's non-carcinogenic, has an MSD sheet, material safety data sheet, like diesel. So people spill diesel all the time.
And it's okay.
Diesel
They know how to deal with it.
Diesel will evaporate over time, and nature can actually break down diesel so there's nothing left. If it's a heavy oil, it leaves heavy metals and contaminants in the soil or the water. Diesel absolutely is a hydrocarbon. You don't want diesel getting in the water course, but if it did, it floats on the surface, it gets broken up by dilutions of solution, and there's organic matter in water, bacteria that will actually eat the diesel and turn
So
it to
those are
C.
the volatile organic compounds.
Yeah, and it turns it to basically carbon dioxide and water. So your diesel will actually break down, if it's in water, to more water and off gas to CO2. So again, if I can get you just to see that clearly we have gas coming in. And that's area 40. Doesn't matter what one you pick. You can pick any one at random. We can be here till 12 o'clock tonight. We can smash every rock up you want. All of them will off gas. Again, just so we don't stink the place out, but just to be sure. Okay. Now the black soot you get is actually part of that, is the soot. Within the soot is sulfur. Okay. So what we're going to do is recycle the catalyst while I tidy up, and then I'll show you some stuff on the computer. And to show that we can recover everything. Any questions just now? Generic or wanting clarification on anything?
I'm actually processing still.
Yeah, that's kind of what I'm thinking too. That's
But I think you're right. I think people say that. They're not looking at this the same way you are.
Well,
That's why they don't understand it.
Well, let me answer one of the things that Vincent said. He said that Sinopec came to China, came from China to Peru. They took their own samples and they went back and they processed it in a process called fire assay. They basically heat it up and they try and vapor off the hydrocarbons. Now I got 22% by volume on one of the samples. And they said, no, that's not possible, because when we tested it, we
No,
got...
45%.
No. I said we got 20% solvent. With the solvent, we get 20% hydrocarbon extraction. And they said we lied, because when they took the same samples back and they did it their way, they get 1.75%. And that initial company passed it over from Sinopec being interested to their sister company, CNOC. Okay, so you can't make the same process fit for all. If you're using experimental in their eyes or proprietary technology, you can't use.
It's not an apples to apples comparison.
You
It's
can't.
that simple.
Yeah, you can't use crude.
You need your process to get these results.
But as you used the analogy, this is high school lab glassware. There it's instantly vaporing. And if you watch down here, if you bring your camera around here, it'll start to strip. There it's happening right now. Look at this, Vincent, because this is important, because this is what happens down hole. It's stripping the hydrocarbons. It'll bring all this down. This is what happens in a formation. It goes in, turns to a gas, goes up to the porosity the rock saturates, and runs back down again. The time we are finished processing this will all be clean. And it will rise up and distillate round there. So you want to come round here, Mr. Wood?
Here. Deep in.
See, we're almost down to just a thin line now. And that's what it does in the formation. Now, there's a process in the industry called huff and puff. In simplistic terms, you have one well, they're generally vertical, not horizontal, and what they would do is either put steam down, they would either put steam down or chemicals down, they let it soak,
And then it perks.
and then they turn the pump the other way and they pull it out. And the technique's called huff and puff, because it's
Sure.
push it down, pull it back
And it
up.
comes up.
Okay.